Place the 555 IC on the breadboard such that its notch faces upward. Connect pin 8 and pin 4 to each other of the 555 timer IC. Now connect pin 2 and pin 6 of the timer IC to each other. Now connect pin 8 to positive rail. Connect pin 1 to negative rail. Now connect a 100 microfarad capacitor between second pin number 2 of timer IC and negative rail such that the positive terminal of the capacitor is connected to pin 2 and the negative terminal of the capacitor is connected to negative rail. Now connect a 1 kilo ohm resistor between pin 7 and pin 8. Connect another 1 kilo ohm resistor between pin 7 and pin 6. Now connect a 330 ohm resistor to the output pin, that is pin number 3 of the timer IC, to any point on the breadboard. Now place an LED with the other end of the resistor to negative rail in series. Now using a jumper, connect the two halves of the breadboard. We are using this jumper to connect the negative rail to the other side. Now our circuit is complete. We are using a 9-volt battery to power the circuit. The 330 ohms resistor is calculated on the basis of the input voltage and the voltage of the LED. We can use 300 to 400 ohms resistor for a orange color LED, which varies for every color of the LED. To adjust the flashing rate of the LED, we remove the second 1 kilo ohm resistor between pin 7 and pin 6 and connect it with a variable resistor called as potentiometer or preset. We are connecting the pin 7 of the timer IC to one end of the preset and pin number 6 of the IC to other end of the preset. By rotating the knob, we can adjust the resistance. By powering the circuit, the LED flashes. By rotating the knob, the flashing rate of the LED changes. We can do this by changing the value of the capacitor. The flashing rate of the LED is inversely proportional to value of capacitor and the resistor. This phenomena depends on the charging and discharging of the capacitor. The discharging rate of the capacitor is controlled by the resistor.